Greetings. I'm Sean Thurston. This is my presentation on rare diseases and disorders, and the one that I selected is called Argininemia, or arginine deficiency, or arginase deficiency. Arginase, it is a non-essential amino acid that the body produces. And what the body does with arginine is basically, since it is an amino acid, it helps break down proteins. So we'll get into the argininemia, what it is, what it does, how it works. You know, we'll cover the whole gamut. All right, argininemia. I hope you can see this well. This is one computer filming another. Argininemia, arginase deficiency, it's a rare inherited disease, and it's not very common. It's not necessarily life-threatening, but it's a nuisance. It can be a problem. Much like anything else, even things as simple as ear infections or strep throat, if it goes left untreated, you can develop some serious problems if you don't take care of those right away. All right, so I don't need I keep thinking I need a pointer, but it's just the mouse here. So this is a disorder that the body doesn't produce arginine sufficiently. It's something you need to break down proteins, and what it also does is it removes nitrogen from the blood supply. So if that nitrogen isn't taken out with the arginine, you have high levels of ammonia in your blood. And high levels of ammonia, I didn't say pneumonia, did I? High levels of ammonia can cause muscle spasm, muscle cramping. If it gets heavy enough, I mean, just think about that, ammonia in your blood supply. Neurodeficiency, muscular deficiencies. If you let it go on long enough, you can develop seizures, brain injuries, brain damage. So it's definitely something you want to address if it's a problem. Now, what's funny is you think a deficiency in arginine would want you to supplement arginine, but the treatment for it actually is to stay away from proteins as best you can with diet in order to keep, you know, the insufficient levels you have, because you may have some, but not totally good enough, or you may not have any. So eating protein and having protein in your diet, which really is necessary. So I'm fascinated with how this whole thing works. I would think you'd want to supplement it, and we'll get into that later then too. But definitely removal of nitrogen is absolutely 100% necessary for homeostasis. It has to be taken out. Okay? You have to have oxygen-rich blood. Nitrogen's a problem. And if you think about the problems that you have, like when you go scuba diving and you develop the bends from the nitrogen that's in your blood supply, joint pain, muscle spasm, headaches, things like that, it's all the same. And the bends can kill you. So this is very relative to that. You don't want that high level of nitrogen in your blood. So this is, like I said, necessary during the processing of proteins. I'm going to try to move this screen up a little bit so you can actually see the presentation, the words. It's kind of hard to see. Hopefully I don't break anything. Okay, so this is a diagram here of what arginase deficiency is. It's a nephrological problem. So it happens in the ureters, the urea, with kidneys. So it's something that coincides with that nitrogen removal through your urination, and through your hepatic and nephrotic systems. So this is basically hepatocyte diagram that shows the arginase working in this cycle and removing the nitrogen. That's just a little example we have. Okay. So, prolonged buildup of nitrogen in the blood supply may result in elevated levels of ammonia in the blood, as we were saying. Effects of elevated ammonia levels, we discussed that. Neuro and muscular deficiency, muscle spasm, muscle tension, muscle cramping, headaches, joint pain, all can be severe. If left untreated, can result in death. You really have to be ignoring what's going on if you let it go that long. So the gene responsible for argininemia is the ARG1 gene. And mutation of ARG1 may produce an arginase enzyme that is incorrectly shaped, smaller, or even less stable than what is needed. Alright, so the cytogenic location of argininemia is 6q23.2, as it says right here, which is the long arm of chromosome number 6. So this is a diagram that shows the long arm of chromosome number 6, where that's located, speaking genetics-wise. It's an autosomal recessive gene, so it basically kind of skips a generation, but you have to have both parents as carriers. If there's just one, most likely not going to happen. You know, those odds are stretched. Males and females have the exact same passage rates, so this isn't a gender-driven deficiency. Argininemia is very rare, affecting only 1 in a million people. So you figure the U.S. population's 330 to 350 million people. Every one out of all those, I mean, it's a very, very small number. Fortunately, there's no evidence that's consistent for the genotype-phenotype patterns that show where this is more prevalent. There's no patterns that say, hey, this community here is prevalent to this due to X, Y, and Z with diet or anything else. This is just a freak thing that happened probably a long time ago that's come to fruition. We can't really see it. I have a pedigree here, and it's just a basic one, so if it's hard to see from this camera, which of course it is, let's try to get a good look here. Well, I'm going to definitely turn in the PowerPoint separately so there's proof that you can actually see this. This is really tough to do in this circumstance. However, so I have a mom and a dad, both carriers of argininemia, but not affected. They don't have the phenotype, but they have the genotype. They carry it. So, 2 carriers, mom and dad, they each have, that couple has 1, 2, 3, 4 children. 2 boys, 2 girls. Okay? First kid is Reggie. He's 42. He marries Millie. She's 24. I bet Reggie has money. So, they have 2 children, and Reggie's a carrier, Millie is not. So they have a son and a daughter. Lucy becomes a carrier, Sylvester is not. Okay? So that's just 1 carrier. Now you've got Betty and Johnny. Betty is mom and dad's the oldest daughter. She's 38, Johnny's 36. Betty's a carrier, Johnny is not. They have 2 children. One of their children is a carrier, but does not have the phenotype. Then there's Ronnie and LaFonda. Ronnie's 36, LaFonda's 33. Ronnie's the son of mom and dad, and they have 4 kids. Calvin, Ruthie, Nancy, and Woodrow. So, LaFonda is a carrier, so you have 2 carrier parents, there's 4 children. You got a 25% chance of one of the kids having. So you got 4 children. Calvin has that lowercase a, he has argininemia. Ruthie is a carrier, but does not have it. Nancy has nothing. She got 2 capital A's from each parent. And then Woodrow has 2 lowercase a's. So I guess you'd have a 50% chance, not 25, to correct my math. So if you have a lowercase a, you're going to have it. If you have, both parents are carriers. Okay? So then Bonnie, the 30-year-old daughter of mom and dad, she marries Tommy. Tommy's a carrier. They have 3 children. Jackie, their only daughter, unfortunately, the only girl, has argininemia. So, alright, so, Options for genetic testing. Argininemia is on the panel for newborn screening. So when children are born, when there's babies, they take that blood spatter from the heel. Argininemia is one of the things they test. They test for so many different things. Another option for genetic testing, you can get a basic, a complete metabolic blood count, a CMP. You get those at hospitals. Argininemia is something that they can look for. They are checking your BUN, your blood urea nitrogen. So most likely your normal limits are 8 to 20 milligrams per DL. I don't remember what DL is. But 8 to 20, so you're probably going to be jacked up pretty high over that 20 mg DL. That's another way they can look for it. Common treatment, argininemia, as I was discussing before, change in dietary habits, avoiding certain amounts of proteins. They're monitored carefully to keep arginine levels lower. Supplemental additions of L-arginine have not shown any success. So taking oral caplets you can get at the store as a supplement, it just doesn't work. It probably is too difficult to do because when you take oral medications, they got to go through the gut. The absorption rate is always lower. It's usually about 20% of what your dose is. So if you take a 200 milligram dose of L-arginine, which would probably give you heartburn, you're only getting like 40 milligrams once that goes through your gut. It's really a pain. So, IV L-arginine infusions are in the process of being looked at. I've had the pleasure to work at an IV bar. It's part of Doc Smiley's urgent care, and it's an IV bar. Arginine is one of the aminos that are being looked into to do intravenously, go straight to the bloodstream, and see if it'd be really interesting if patients with argininemia can function better, absorb the, remove that nitrogen, absorb the drug better, the amino, and see if that works. It's really interesting. So, these are my references. I've used the NIH, Organization for Rare Diseases. I got a lot of references, done a lot of research on this. I'm going to be sure to email this presentation in to Dr. Stansel so you can see what I have here, because it's pretty difficult to see. But I hope my presentation was at least decent decent at the least. Thank you so much. Good luck to everyone. This has been a really great class. I've learned a lot. Thank you.